Okay, so we're doing factor by grouping. We pulled out 6x out of the second one, and out of the first one, we just did perfect cubes. Now, the rules for factor by grouping are going to be the same. Do you see two parentheses that match? Yes. You see the x plus 2's match. So what we're going to do is we're going to factor out by undistributing the x plus 2 from both terms. So we're going to have an x plus 2 in front. Then in the second parenthesis, what's left over? Everything in blue. X squared minus 2x plus 4 plus 6x. So all of these rules are the same. Factor by grouping rules are the same. The only difference was instead of doing a GCF, we did cubes. But you can do that. You're allowed to do that. Now, does anything simplify?
Yeah.
Leave some like terms in the blue parenthesis. So x squared plus 4x plus 4. What piece? Ooh, can that trinomial be factored by guess and check?
Yes.
All right, so if you haven't done it yet, don't yell it out. If you haven't done it yet, factor that trinomial by guess and check. Factor that trinomial by guess and check. Oh. X plus 2.
See how annoying that is?
I think it's beautiful. Then at this point, do you notice that we have 3 factors, but they're all the same? So let's rewrite it as x plus 2 to the third power.
See how such a headache.
Oh, it wasn't that bad. No, it was just knowing how to get started, but it was factor by grouping. We've already learned factor by grouping.
How did you just do x plus 2 to 2x plus 2? How did you just
Well, you know how we take out a GCF?
Yeah.
So this was our GCF, and we factored it out of everything. It was our GCF. We factored it out. We undistributed it. Instead of putting it in, we took it out.
Yeah, I just don't get how one of them is good.
They don't. Okay. You know how if I have this, is there GCF? Let me change it. Is there a GCF?
X.
Okay, so if I put X out here, what's left over?
5, 9, 11.
So how did one of those X's just go away? Do you see how it's the same
Yeah.
thing? Like you're factoring it out,
Yeah,
and it
okay.
becomes just that one. All right, grab your graphing calculator, and on your graphing calculator, we're going to discover something cool about these graphs and these solutions.
No, they aren't.
I'll use my graphing calculator on my computer. Maybe. Yeah. All right, I put on there to graph y equals x plus 2. It's loading right now. It's coming. Yeah. I'm sorry.
Oh, X, X.
What do you want to do? Oh, you want to plug it in so it's going on? Oop. Is that what you're talking about?
Oh God. Oh no.
Go to mode.
I know.
Okay.
I realized when it made a curve, I was like, oh no.
go ahead and get that graph. It should be what kind of graph? What linear?
Linear.
My question is, where is the x-intercept? The x-intercept is at -2. And this graph, it just passes right through -2. So now what I want you to do is go to y equals, and I want you to change this so that it is x plus 2 quantity squared. And then hit graph, and let's look at the x-intercept now. The x-intercept is the same, but the graph's not. Now, at the x-intercept, does it just pass through? Right. It comes down, it touches it, and then it goes back up. Let's see what happens if we do x plus 3 squared, or x plus 2 cubed. Sorry, I switched the wrong numbers there. X plus 2 to the 3rd power. What's happening at that -2 now? It is passing through, but is it just going straight through like it did with a line? What kind of graph is this?
Cubic.
Yeah. This is a cubic graph, and it's doing that little cubic thing right at the x-intercept. What's going to happen if we make it to the 4th power? You guys probably do it faster than me. This thing's slow. So it doesn't look like a parabola, it looks like a quadratic, it looks like a fourth, but it still comes down and touches at -2. What happens if we make it to the 5th power? Can you guess before we do it?
Yeah.
Can you? If there are an odd number of x-intercepts, if there are odd number, and if there are even number, what happened? If there are odd number, if there are even number. Now that's just with one x-intercept. Let's go back and let's make more than one x-intercept. Let's say, let's clear this. Let's do x. Yeah, we'll just do x, and then we'll do parentheses x minus 5. Okay, where should the x-intercepts be? The first one, x equals 0, and the second one says x minus 5 equals 0, so the second one is going to be at x equals 5. That is something that we've done a few times in here, finding those x-intercepts. We set them equal to 0. So we should have it at 0 and 5. And what happens at those? They just pass through at 0 and 5. But if we go back to our y equals and we change one of them to x squared, either the x or the x minus 5. Make one of them x squared. Let's just do the second one, it'll be easier. And now at -5, it does that little parabola looking thing at -5, but the x itself at 0 is just to the 1st power, so it just passes through. What if we make them both squared? So you might have to insert or just rewrite it. Second delete is the insert button, so you don't have to rewrite it if you don't want to. Or you can just rewrite it. You missed what I said. Second insert, second delete. We'll do x squared, x minus 5 squared. And what's happening at each of these intercepts now? Going down and touching it, and then again. So if I make, let's make the second one, let's make x minus 5, let's make that to the 3rd power. Whoop, oh, I did it wrong. Don't look at mine. I did it wrong. I put the 3 in the wrong spot. Why is it facing down? Why is that quadratic part facing down now? So what's the degree of the graph for this one? What's the degree for x squared and x minus 5 to the third? It's to the fifth power. The degree is to the fifth, so it's going to be odd. It's going to be like this kind of graph and behavior. It's going to be odd. And that's why it has to start way down here, come up, touch the x at 0, and then come up again and have that little cubic looking thing at x minus, or at top. So kind of see what's going to happen today. We're going to be graphing, and when we have, that's one thing. When we have, this is on the paper of notes that you have the actual packet. When we have things that are repeated solutions, take a minute and write some notes to yourself. What happens if there's 2 solutions? What happens if there's 3 solutions at the same number? What happens to the graph? So when we had x minus 5 to the third power, do you have the packet? So if there are repeated solutions, write yourself, some notes about what happened to the graph when there were 2 of the same solution. We had x minus 5 squared. It didn't just pass through it. What happened? It touched it and went back the same direction. It looked like a parabola at that point. What happened when there were 3 solutions? Wasn't working so well. So when there was 1 solution, it just like passed right through. When there were 2 solutions, it came and it touched it and then went back. What happened when there were 3 solutions? Did it just pass through? Yeah, it kind of looked cubic-like. There was something it's called a point of inflection. It made a little cubic right at that point. So it did pass through, but looked cubic. All right, these are the things that we were seeing. The solution is when y is 0, what the x-intercept is. So, like this one up here, we didn't do those, I just made some up, I guess we did that one. 0 equals x times x minus 5. X equals 0, x minus 5 equals 0. So the solutions are 0 and 5. Remember doing that stuff before? So we're doing that again today. It's just you're going to have multiple solutions that are the same number. All right, so let's do an example. What your homework's actually going to look like. Solving a polynomial equation by factoring. So we're going to go ahead and factor this to start. All right, how do we do factoring? What's our first step? GCF. Is there a GCF? All right, so take out that GCF. We have left over x squared minus 6x plus 9. And then what's left is a trinomial, so we factored out by guess and check. X squared minus 6x plus 9. That second sign tells me that both signs are the same. The first sign tells me that they are both negative. So what multiplies together to give me 9? But adds to give me negative 6. Negative 3, negative 30. So I'm allowed to write the squared because there were 2 of them. That's why I wrote the squared, because there were 2 of the same factor. Now this is a review of what we've done before. At this point, you set each factor equal to 0. You set each factor equal to 0. So we have 2x equals 0, and we have x minus 3 equals 0. Our other factor is also x minus 3 equals 0, but why would I solve both of those with the same number? So if I divide this one by 2, I get x equals 0. If I add 3, I get x equals 3. But there are 2 of those groups. So let's think about what that means for the graph. The original, oh, I'm sorry, I didn't write the answers. 0, 3, there's my answers. So now for the graph. The original question has what degree? 3. So what does the graph have to look like? End behavior has to start, down, go up. That's how all cubics look. And then we look at the leading coefficient of 2. So does that flip this graph? No, it's positive. So I know that the graph is going to look something like that. I know that the x-intercepts are at 0 and at 3, because I just solved to find those. I can also find the y-intercept. What is the y-intercept? Oh, can we find the y-intercept? Is 0. We look for the constant. You plug in 0 for x, 0. Okay, and then we know it's supposed to look like this. So the graph's going to come up. It's going to pass through. What's it going to do at 3? 3 is repeated twice, so it's not going to pass through. What is it going to do when there's 2 of them? Right. It's going to kind of look like a little parabola right there. It's going to touch it and go back up. Now, if you type that in your calculator, we can get a more accurate representation of the graph, but I want you to be able to do it without the calculator to show that you actually understand what these numbers do. But we do have our calculator to check it. Here, we'll do this faster. Oh, I pressed the button, sorry. Can you guys see that? Just kidding. So you graph it, and we can see that our graph was pretty accurate. How could I be more accurate if I needed to with my graph when I was putting it on paper? How could I be even more accurate with my graph? Yeah, I could find the min or the max. There's a max right there. Where else could I go? If I go to the table, you go to the table. Okay, go to the table, second table, and then there's some points that we could also plot for accuracy. Excellent. All right, this next paragraph, this just talks about the repeated solutions, saying that when a factor is raised to an odd power, the graph crosses the x-axis. When the factor is raised to an even power, the graph touches, but does not cross the x-axis. The things that we've already figured out. That's what that is just summarizing. And then we have some student practice, but I'm going to kind of participate in these student practices because there's a tiny little tricky part to it. So this is the same that we just did together. What are we going to do first? GCF. Is there a GCF? Okay. It is 4. After we take out our GCF, then what do we do? What do we do? Guess and check. So that 4 comes down, and then we just guess and check. But this is an x to the 4th. So we make it x squared. Good. And then we've got a plus sign with the 9, but it's a minus sign with the 10, so it's both got to be minus. And then 9 and 1 is going to give me positive 9 and negative 10. Now, do you mean factor again? Yeah. So how do I factor x squared minus 9? It is a difference of squares. X squared minus 1 is also a difference of squares. Remember, I told you that's my favorite kind. We just keep going. So we did a difference of squares and a difference of squares. Our goal is to solve this. So can we factor any of these further? No. So we're going to set each factor equal to 0. What do I do with the 4? My goal is to find what x equals. What do I do with the 4? Ignore it. Oh, poor 4. No, it doesn't affect the x's because it doesn't have an x. So this 4, if I set it equal to 0 even, it doesn't tell me an answer. So ignore the 4. If it had an x by it, I wouldn't ignore it. The other ones I'm going to set equal to 0. I am going to get 4 answers. What am I going to get? Negative 3, positive 3, negative 1, positive 1. I have 4 answers, but since some of them are negative and positive, I'm going to go ahead and write plus minus 1 and plus minus 3 instead of listing all 4 of them. That's way too much work to list 4 numbers. So we'll put plus minus instead. So what does 4 terms, not 4 terms, what does degree of 4, the original question, has a degree of 4 look like? Okay, so is it going to be negative? Is it going to, no, it's positive. So it's going to open up. And we have x-intercepts at negative 3, negative 1, positive 3. Where's the y-intercept? At positive 36, so that's about here, right? I don't have numbers on there. You don't know my scales. We're just sketching it anyway. So I know it's going to pass through the graph at all of these points. And we know what it's supposed to look like for the end behavior, so you can just kind of guess what's going to happen in the middle. Now, if you wanted to know if you did it right, you could graph it on a calculator. It does look something like this. We're not going to take the time right now. We're just going to move on. Does anyone have questions about that? Why did I just pass through at -3? Why didn't I do the little touch? Because there's only one of them. There's only one of each of these. All right, other one? Yeah, it is. It goes up to 36. All right, I'm going to put this one on a different sheet of paper because I wrote big. But what do we need to do first for this one? We need to make it equal to 0. So you need to make it equal to 0 so that you can solve by factoring. Is that how you would have written it? Is that how you did write it? I probably shouldn't have written it that way. What should I have done? 2x to the 5th minus 14x to the 3rd plus 24x. Okay, what do we do? GCF. Check for GCF every time there is 2x. You have x to the 4th minus 7x squared plus 12. We have a trinomial left. We're going to factor that by guess and check. X squared and x squared. What are the signs going to be? They're both going to be minus. One's going to be 3, one's going to be 4. Can we factor any of this stuff further? We can. Right, we've got a difference of squares in that second parenthesis. Have we factored it as far as it'll go? Okay, so we're going to set each factor equal to 0. Should I bother with the first factor 2x? Why? There's an x in it. Excellent. So we do that. Then we've got x squared minus 3 equals 0. X minus 2 equals 0. And x plus 2 equals 0. So you've factored all of them, set them all equal to 0. What's my first x? 0. I'm going to skip that one for a second. What's my third one? 2, and my last one is -2. Yes, those will be plus minus. How do we do this one? How do we solve that? Add 3. I do have to square root it, but there's this rule, when you square root it, you're going to get 2 answers, plus minus. So we're going to do that. You've got to put the plus minus in it. That x squared tells us there's going to be 2 answers. One is plus and one is minus, and square root of 3 doesn't square root, so I just leave it as square root 3. So our answers are 0, plus minus square root 3, and plus minus 2. We have 5 total answers. The original question, was the degree 5? We have 5 total answers. Okay? All right, so the next one says, it's the same stuff we're doing, except it says f of x, but it wants you to find the 0. So what do we need to do for our first step to find the zeros? You make f of x 0. Then we're going to solve by factoring, so what should we do? GCF, is there a GCF? What is it? Alright, so you could tell me 2, but you want to make it easier on yourself. If there's a negative in front, include that as part of your GCF. So make your GCF -2, so it will be easier for you to factor the rest of the way. So that's gonna give me x to the fourth minus 8x squared plus 16. I'm gonna stop talking for a moment while you factor it the rest of the way. Excellent. I see good stuff happening on your papers. How do you factor 3 terms?
Oh, I know.
One thing repeated. So repeated. Yeah. So what's your insight? And then we're gonna. Okay, so I walked around and saw that you guys were getting x squared minus 4 and x squared minus 4, but then those factor further to x plus 2 and x minus 2, but twice. So when we find our answers, we're going to have repeated solutions. I do want to show you, though, if you were just simply factoring this, you would write x plus 2 squared, x minus 2 squared. You would write it that way if you were just factoring it. But since we're solving it, we will keep going. And so, there we go. So we have repeated solutions. Both of these are repeated. And it says to sketch a graph. The accuracy of the graph just needs to have the x-intercepts and the y-intercepts on it. That's what I'm looking for, the accuracy when you do your sketching. So I know that my x-intercepts are at -2 and +2. I haven't found my y-intercept yet. You look at the original question. What's the y-intercept? -32. So it'll be way down here at -32, but you can choose whatever scale you want to count by. So that's fine. And the original question is what degree? To the 4th, but there's a -2 in front, so it's got to look like that. It's got to be the upside down kind. So when you connect it, since there's repeated at -2 and +2, it's going to have that parabola looking thing happening at -2 and +2. And it opens down. Okay? All right, I'm going to pause the video. I want you to try 3 and 4. See if you can factor them, see if you can sketch them without using your calculator. You can use your calculator to check, but see if you can answer those two. So for this second one, I got 3 solutions, but none of them are repeated. So we're just going to pass through. Also, it is cubic. Whoops. It is cubic. So it's going to have that cubic end behavior. That's what your graph should look like. All right, we are almost done. What we have for the rest of the examples are going to be equations that you can't just sit down and factor. They are factorable, but you can't look at them and just factor the stuff that we've been doing. But they are factorable. So we have this test that we can do to figure out factors when you can't just look at them and factor. So there's this rational root theorem, and it talks about using the last term and the coefficient of the first term. And it's in the order that you wouldn't think. The last term is what you use first, and the first term you use second. And we're going to make a fraction p over q. Factor of the constant term and factor of the leading coefficient is where I'm going to get my p over q. Okay? And this lists only possible solutions. It does not list every solution. I know it, let me rephrase that. Every p over q is not always the solution. It's just possible solutions that we can choose from to narrow down and find our actual solutions. So this is how it works. We're first going to figure out the factors for p and to figure out the factors for q. So we look at our last term, 20. What numbers multiply together to give us 20? 1 and 20, 2 and 10, 4 and 5. I'm going to list those 1, 2, 4, 5, 10, 20. I make a list of my p. Those are all the factors of 20. Then we're going to make a list of all of our q's, which are the factors of, what's in front of x cubed? 1. Okay, so all my factors of 1. Now, before I go any further, is there any other number that can divide into 20 besides the ones I've given you? Anybody come up with any, and I don't mean decimal, I mean whole number, or any other whole numbers that can divide into 20? You all prefer to say that at the same time. And somebody else said it, you weren't loud enough, sorry. Did you say it too? I screwed you at you. Give that to somebody else. All right. So negatives work also. So really, all of my possible solutions are positive or negative of every single one of these numbers. Okay, that's fine. Now, to find the actual possible solutions, we're going to find every combination of p over q. So I'm going to take every p and put it over every q. So we're going to have plus minus 1 over 1, plus minus 2 over 1, plus minus 3 over 1. No, just kidding, there's no 3. Just kidding. 4 over 1 is what I meant to do. Plus minus 5 over 1, plus minus 10 over 1, and plus minus 20 over 1. So those are all the possible solutions. I kind of said this, but I didn't totally really say it. Why didn't we just factor this by grouping? Like if I do grouping for this one, it's not going to happen. So that's why we needed to do this other, this rational theorem. All right, so now what we're going to do is we're going to test possible solutions using synthetic division until a solution is found. So what is our first solution that we could possibly use? What's the first solution we could possibly use? We're almost done, I promise. See all my possible solutions? What's one that we could possibly use?
5.
Let's use smaller than that. 1. Let's use 1. Let's try 1. Let's try. Let's test if x equals 1. We're going to test that by dividing it using synthetic division. We're going to see if x equals 1 is actually a solution. So we know synthetic division. 1, -8, 11, 20. Bring down the 1, multiply, add, multiply, add, multiply, add. Is 1 a solution? Nope. What also can we test? Before that. -1. So I've got synthetic division again. 1, -1, -9, +9, 20, -20, 0. Is -1 a solution? Yes. All right, we've gotten one of our answers. Woo. That's one of our answers. Now, let's look and see what's left over. What's left over? Remember when we did synthetic division? The first one is a coefficient, but just a degree less. So the first one's going to be x squared, then minus 9x, plus 20. Is that something we can now factor? Guess and check. X, positive 20, but minus 9, so minus 4, minus 5. That one does factor. Can we solve it then? So all of our solutions are -1, +4, and +5. So we just had to find that first solution and take it out of the equation, factor it out of the equation, and then you can factor what's left over. Question? Next example. Last example. What if the Q is not 1 was her question. So I'm going to skip the student practice for a moment. We can go back to it if we need to, but I want to go to example 4. Make sure that we do that before you leave. Okay, so example 4, you will see that P is 12, but Q is 10. So 10 factors are 1, 2, 5, 10. And then 12, the factors are 1, 2, 3, 4, 6, 12. So what we're going to do is we're going to do our P over Q. I'm going to first use just that Q with all of those P's. So I'm going to stay organized so I don't skip any. This one will. Not all of them will. So I'm going to do plus minus 1 over 1, plus minus 2 over 1, plus minus 3 over 1, plus minus 4 over 1, plus minus 6 over 1, plus minus 12 over 1. When you look in the book, they did not. You just walk in. Yeah. No. When you look in the book, they did not write 1 over 1. They just wrote 1. They just wrote 2. That's how I would write it. I'm just writing it as 2 over 1 right now since we're first seeing this, so you know where both numbers are coming from. Okay, now we're going to do the same thing again, but let's use 2 as the bottom number. So now I'm going to do every single P over 2. So our next one would be plus minus, but didn't I already do 2 over 2, kind of? What's 2 over 2? That's 1. I've already done that one. I'm not going to rewrite it. How about 2 over 5? I'm sorry, 1 over, I think I said it in the wrong order. I've already done 1 over 1. I've already done, I need to rewind. We're doing all of these over 2, right? Okay. I think if I get rid of this, I'll stop being confused. All right. So I'm going to do 1 over 2. We haven't done that one yet. But we have done 2 over 2. We haven't done 2 over 5. I mean 3 over 2. I'm sorry. I'm just doing 3 over 2, then 4 over 2, then 6 over 2, then 12 over 2. Except some of them are repeat. Huh? 4 over 2 is a repeat. 6 over 2 is a repeat. 12 over 2 is a repeat. So I've done all of those. Now let's do all of those numbers over 5. 1/5, 2/5, 3/5, 4/5, 6/5, 12/5. Huh? This is kind of long, and
There's a lot of them.
yeah, but they're not all going to be like this. I'm showing you one that is harder than any of the ones I've given you for homework, so you would know what to do, and the homework will seem easier. All right, then we're going to do everything over 10. But some of these repeat. I think some of them do. 1/10. 2/10 is what number? That's a 5th. We've already done that. 3/10 we haven't done yet. 4/10 repeats. That's 2/5. 5/10. Nope, there isn't 5/10. 6/10 is a repeat, and 12/10 is a repeat. So we're done. Okay. What this is telling us is these are all the possible solutions. All the solutions are in there somewhere. How many solutions are there? No, how many real solutions are there? 4. So all 4 answers are somewhere in here. No, you know what? There's no way I'm going to just start at the front. Well, go for it. We're going to type it in our calculator to give us an idea of what the answers really are. So type this in your calculator. Type it in. Yeah, you can do my hand. We're going to type it in the calculator. Where's my calculator? Is it working now? You don't want to be under my camera anymore? You guys type it in your calculator. I'm doing it too, once I find it. Does it look like mine? Does it look like mine?
Yeah. We have the exact same. I'm so confused. I didn't delete a graph from before and it's the exact same graph we had. Because it didn't draw another graph. That's the 136.
Okay, so what we're doing with this graph is we're going to kind of figure out what solution we might want to try. We're going to definitely limit it down because you look here and you see, all right, it doesn't hit at any whole numbers. So none of the whole numbers would work. So Jacob, had you started at 1 and -1 and 2 and -2, like you would have been going forever because none of these answers are whole numbers. They're all fractions. So let's guess maybe at a place that we could start. Or how could we actually find a place that we could start? We need to find the x-intercepts. How can we find the x-intercepts? second calc, and 0. The zeros, number 2. So let's start at the left one. Pick a number that is left of this x-intercept where I'm pointing right now. What's to the left of that for sure? -2. So I type -2 and I hit enter. Whoop, something happened. Because I didn't hit -2. Okay, so then what is to the right of that point? -1. Well, yes, but there's other stuff in there, so I don't want to confuse the calculator. And then guessing maybe -1.5. So it tells us the 0 is at -1.561553. That is not super helpful for me right now because that is not an exact answer. So I'm going to try a different one. I'm going to try it again. We're going to do second trace 0. Let's try this one right here that looks like it's maybe at -0.5. So we're going to do our left bound -1 and our right bound 0. And then guess -0.5. So I'm guessing. Is it at -0.5? Okay, so it says that the 0 is at -0.5. So I'm looking at my graph to get an idea of what I can use for synthetic division. So now we're going to use synthetic division at what x? I'm not going to use 1/5. So I'm going to use synthetic division at -0.5. I'm going to put in my coefficients. 10, -11, -42, 7, 12, do synthetic division. And what's nice is, even though it's a fraction, it multiplies and gives me a nice whole number still. I couldn't think of that. That's not right, is it? It's not 36, it's 34. Okay. So I'm doing my synthetic division. I do my synthetic division. We knew that -0.5 should work, and it did. So now what do I have left for my equation? Nope, not squared. So this is what I have left. Can I go ahead and do factor by grouping? But can I do factor by grouping to solve it? To factor it? Can I do factor by grouping if I group these? Will something factor out? Factor by grouping work? So guess what? Let's find another factor that works from our calculator. I told you this is longer than anyone that I'm going to give you in homework, though. You are going to have to do this kind of stuff for homework. So I'm going to check the third one. I'm going to pick something to the left and something to the right. So 0 is to the left. It's okay if you're watching me instead of doing it because of speed. I forgot to do second trace. No, what? Did I? No. Second trace. 0. I pick 0. And then I'm going to pick 1. And I'm going to pick 0.5. But it's not 0.5, it's 0.6. So what is that as a fraction? What is 0.6 as a fraction? 3/5. So 3/5 should work. I'm gonna check it, but when I do this, I'm gonna do 3/5 off of the last answer, not off the original, off the last one. So I'm gonna do synthetic division with 10, -16, -34, and 24. I'm gonna do it off of that one. 10, 6, -10, -6, -40, 24, 0. So did that work? It worked. So we have 2 answers so far. We just have to find the other 2. So now what we have left is 10x squared minus 10x minus 40 equals 0. But remember when we found our 0 on our calculator, it was a horrible looking decimal for one of them. If you try to factor this one, it's not going to factor. It is not factorable. So we have to remember our other ways of solving for x when we can't factor it. To use the quadratic formula. Yep. You are not a child. All right, let's sing the quadratic formula. Ready? X equals opposite b plus or minus square root b squared minus 4ac all over 2a. Don't worry, we're right at the end here because this is going to give us our last 2 answers and we're going to be done. So we're going to need quadratic formula on 10x squared minus 10x minus 40. So x equals 10 plus or minus square root 100 minus 4 times 10 times negative 40 all over 2 times 10. And then we simplify. 10 plus or minus square root of 700 over 20. Okay, then we say does 1700, yes it does, simplify. It's not a perfect one, but it does have a perfect square that will come out of 1700. 100 and 17? Okay. So now we have 10 plus or minus 10 square root 17 all over 20. Now this would be the answer if I couldn't reduce anything, but I can reduce something. So we can write this as 10 over 20 plus or minus 10 root 17 over 20. And what happens to those 10s and the 20? They reduce to half. You can write it like a half plus or minus square root of 17 over 2, or you could write it as 1 plus square root 17 over 2. Either way would be fine. But the good news is we found the other 2 answers, and that's why we couldn't really find them on a graph. That's why they were horrible decimal, because they had a square root of 17 in them. So now we're going to list all of our answers. We're going to list all of our answers. What was the very first answer we got? Negative a half. Then we got 3/5. And then we got 1 plus or minus square root 17 over 2. So we have all 4 answers. Those are fun. So when you do your assignment, there's only one question that you're going to have to use a quadratic formula for. All the other ones should factor nicely. You can use your calculator to give you an idea of what to try, but you need to use synthetic division. Do not just look on your calculator and write down all the answers and be done. is you need to show me using synthetic division that you pulled the first one out and factored the rest of it. So you need to have that work in your homework when you get to these times. The homework is on the paper that I handed you. One's on the back of Puzzle Time and then the other paper. It is in the book, but I just printed it out. And then when I printed it out, number 25 didn't print. So you need to write number 25 under 24 there so you have it. Number 25 didn't print. So see number 24? It's right underneath that, but number 25. Number 25 starts the kind where you do the P over Q thing. If you want to start with the challenging ones first, start with the last question and work your way forward. Doesn't matter to me if it's in order when you turn it in. If not, that's fine. Start at number, what do we start with? 3. Yeah, right here.
Oh, I was looking at it.
25 didn't copy. Sorry. You will need separate paper. You're not going to be able to factor all of these in that tiny space. Sorry.